Welcome to this podcast from the Triple Helix Cambridge June Café Scientifique event, sponsored by the Medical Research Council. I'm Mira Senthilingam from thenakedscientists.com. For this month's café, Professor Jenny Morton set out to dispel any myths about the intelligence of sheep, as she provided new insight into the true personalities and decision-making abilities of these woolly animals. She discussed her work using sheep as models for Huntington's disease, a neurodegenerative disorder caused by a mutation in the Huntington gene. The disease mutation is dominant, which means that any child of a parent affected by the disease has a 50% chance of inheriting the same mutation. The disease is also late onset, typically affecting patients in their 40s, with symptoms of involuntary muscle movement and a decline in cognition. It's a very debilitating condition with no treatment currently available, so creating better models for the disease is crucial to help scientists find some methods of prevention or treatment. I caught up with Jenny before the event to find out more.
Okay, tonight I'm going to talk about Huntington's disease and how we can use new models, animal models, to study it.
When it comes to diseases like Huntington's, what do you like with an animal model? So what do you need from one, and therefore which ones do you use?
Well, ideally we'd want a model that actually recapitulated the features of the human disease, but that's just impossible in adults because in humans the disease doesn't start till most people are about 40, and very few animals live that long, and besides which very few scientists last that long either, so studying an animal model that was true to the humans would be very difficult. So what we really look for depends on what you're asking. So if you want pathology, you want the pathology to be similar, and if you want behaviour, you want behaviour to be similar. And that's actually very difficult when you've got a mouse, which is a quadruped, who has a very different kind of life from a human.
So when you move away from mice, which animals do you prefer to move towards?
Well, we haven't got a choice at the moment because the only good models for Huntington's disease are rodents, mice and rats. The model I'm going to talk about tonight is a new model, which is a sheep model, which has only just been developed. And in fact, it's in its very early stages. But tonight I want to tell you about the sort of possibilities for this model and why I think it has great possibilities.
What made you first move towards sheep models then?
Recently, people in New Zealand and Australia, some scientists there, have developed a transgenic sheep that's transgenic for the Huntington's disease mutation, and this offers us a wonderful possibility of studying not just the pathology for which they developed the model, but also for things that they haven't really got any way of testing, like behaviour.
What do we know so far then about brain activity then in sheep, and therefore how they could be used perhaps as models?
We know relatively little, actually. So sheep have been used as models for many things, for understanding birth processes, understanding maternal recognition, for development of replacement joints, arthritis, cancer, but they've really been used for studying neurological disease. So I can't answer that question. We don't really know.
So how are you setting about finding out just what, I guess, then the cognitive abilities or the abilities of sheep generally are?
Well, I started out by buying some sheep and then getting to know them and seeing what they were capable of doing. And I was very surprised. They're much smarter than I thought they would be. They've got real personalities. And all of these things are good if you want to look at decline that's related to human behaviour. So personality, for example, changes in personality are very important in Huntington's disease. It's very hard to see a change in personality of a mouse.
And so how were you able to see, I guess, these traits in a sheep?
Well, we designed some experiments based on human tasks where we could actually measure the changes in behaviour and quantify them. We used the sheep one at a time, so we ran them through a maze test, which gave us the opportunity to look at the way they learned and remembered and their cognitive flexibility, how flexible they were in understanding when you were going to change a rule on them, which is a good test for human ability as well.
So could you give an example then, so as to a type of test and how they then establish what rules, I guess, are of the test and therefore when rules change?
The task that we use, which is actually the simplest task to understand, is called a two-choice discrimination task. And this is basically when you're presented with two things that are different and one's going to be rewarded, how quickly do you learn to always go for the one that's rewarded? So that's the first rule. You learn that one of these things is going to be rewarded. And then what the experimenter can do is what's known as a reversal. And that is you switch the rule. So the previous rule was object A was rewarded, and then you switch to object B is rewarded and object A is no longer rewarded. And that's called a reversal. And it's quite sensitive because if you have brain damage, you find it quite difficult to switch to the new rules. So people with brain damage tend to perseverate on the first rule that they learned and not learn to switch to the new one.
So is this something you see happen in patients with Huntington's?
It is. By the time patients are mid-stage in their Huntington's disease, they have real difficulties doing reversal learning, and we use it a lot as a sort of sensitive test for when a part of the brain called the striatum that degenerates in Huntington's disease, when that goes, patients and mice actually have problems doing reversal learning.
And how did the sheep perform with this?
The sheep were great. The sheep learned to do reversals very easily, so as easily as a monkey or a human can do it.
Well, I was going to ask how they compared then to other animals, and therefore I guess this gives more evidence for using them as models as well.
They compare very well to rodents, which is the currently used models, and they're not nearly as good as people, but they're actually pretty good as a small monkey.
So now that you've seen this ability, I guess, with the sheep, is the next step to prove a bit more about what they're capable of first, or are you now able to start perhaps using them as models for HD?
Well, just that one test alone, the reversal learning, that a normal sheep can learn to do a reversal, is enough for us to start using the Huntington's disease sheep, because you would predict that in the Huntington's disease sheep they would have difficulties with that particular task. So just that one test alone is enough to allow us to start testing the Huntington's disease sheep. We have a group of sheep in Australia. We're just waiting for them to get a little bit older at the moment, because at the moment the best sheep we have are about a year to 2 years old, which isn't. We wouldn't predict that we'd see a deficit yet, but in another year or so we should be able to start testing them.
And I guess just lastly then, what do you imagine as almost, I guess, your end goal with all of this?
Well, my end goal is actually based on the fact that these animals should have quite a slowly developing disease, and they are a way that we can test preventative therapy. So we can give an animal, like a sheep, a therapy that we would predict would slow or prevent the disease, and hopefully in a few years we would be able to see a difference between animals that hadn't been treated with that and animals that had, and that would make a big difference to human patients.
Professor Jenny Morton from the University of Cambridge, revealing the true personality of the previously misunderstood sheep. Now, after the event, we opened up the floor to some audience questions, starting with a query about the intelligence of sheep in comparison to a monkey.
The question is why monkeys might be slower at learning than sheep. Monkeys aren't slower at learning once they get the task, but they're much harder to train to do these sort of tasks. So with a monkey, to do the same kind of task, you have to put them in a box and get them to learn to touch a computer screen. So typically they're done with the choices are made on a computer screen. Getting a monkey to go into a box willingly, realise that it's going to be rewarded, it's quite scary for a monkey. Walking down a lane for a sheep isn't that scary. I think the time isn't the intelligence of the monkey. I have to say monkeys are almost certainly way smarter than sheep, but training them takes a lot longer.
This was followed by a question about the transgenic sheep created by Jenny's team, and whether drugs are currently being tested on them.
Yes, we do have experimental drugs lined up to test them, and no, we haven't started testing them because I don't currently have anywhere to test my sheep. So I have about 1,000 sheep in Australia, half of whom carry the trans gene, but we actually don't have a behavioural testing facility for sheep because nobody does behavioural testing in sheep. So the people who fund me are actually considering building a facility that we will be able to test sheep in an environment that's suitable. Drugs though, yes, there are already drugs or therapies that other scientists want to test. The main one being things that we cannot test at the moment in humans, gene therapies in particular. Now, Huntington's disease is a monogenetic disorder, so it's a great target for gene therapy. But gene therapies that cause irreversible changes in your genome, we've no idea how safe they are. And these are not like a drug that you might take, you may have an adverse reaction to, and you can hopefully wash it out. A gene therapy that reverses expression of a gene irreversibly may be a very bad thing, and we don't know that. So they are the sort of things that we would want to test first, and also preventative therapies. It's very difficult to test ethically patients who haven't got disease yet, even if you know they're going to get it. And part of the problem with Huntington's is we don't know when a person's going to get their disease. You would typically get it in your 30s or 40s, but you may be 70 or 80 before you get it. So when are you pre-symptomatic? And when can you test a preventative therapy? And with the sheep, we hope to be able to test things that might prevent disease rather than cure the actual symptoms.
But what about alternative therapies to treat Huntington's?
So the question is about alternative therapies for Huntington's disease. For example, trehalose, which is a sugar which has been shown in some animal studies to have improving effects. Am I prepared to try them? Yes, absolutely, if there's evidence that they work. Unfortunately, the evidence for trehalose, I think, is quite weak. But I think there is good evidence that some behavioural therapies will at least improve or delay the onset of symptoms. Yes, absolutely. I think if it's got a scientific basis, we should investigate it, whether or not it's unexpected.
And going back a few steps to the symptoms of the disease, do all Huntington's patients typically have the same symptoms once the disease begins onset?
Yes, they are typical. Huntington's disease patients all eventually end up with motor abnormalities. Most of them have the chorea that defines the disease, so this abnormal dance-like writhing movements. That progresses into a rigidity like Parkinsonism until by the end stage patients are unable to move. They're typically unable to move, or they have terrible dystonias and chorea that turns into very abnormal movements. As well as that, I think it's reasonable to say that nearly all HD patients have cognitive problems at the end. They have what's called a subcortical dementia. So it's not like the dementia that you get in Alzheimer's disease, but most patients who go the full course of their disease end up with dementia. And this is actually the thing that they find most distressing, is that their cognitive faculties are gone, and it's the things that make them human that disappear. The executive, the ability to make decisions, the ability to recognize people, the ability to socialize. Plus, most HD patients have psychiatric problems, behavioral disorder, depression. Something like 75% of HD patients have major depressive illness, anxiety, paranoia, schizophrenic-like symptoms. Before the gene was cloned, about a third of HD patients were actually misdiagnosed with schizophrenia. And these are inescapable. You know, you end up with this terrible complex of symptoms. The progression may vary between patients, but most patients end up with some or all of these symptoms.
There were also concerns that with this new insight into the abilities of sheep, that we could perhaps have also misunderstood or not appreciated the full potential of other members of the animal kingdom.
So the question is that we've recently discovered how intelligent rooks and crows are. Have we underestimated other animals? I think probably. I certainly underestimated the intelligence of sheep. Sheep are never going to be able to do differential calculus, but they reason, they have processing that's measurable. I think we will be surprised by other animals if we can figure out a way of testing them. But in the defense of normal people, sheep are also very silly. When you get them together, they can be very silly. They're also very destructive. Instead of going, oh, I could go around there and get that, they just push their way through. So they seem silly, but that's just being a sheep.
So whilst there is a lot of hope for sheep as models for Huntington's disease, the work is still in its early stages. But now that their cognitive ability is better understood, the tests for drugs and treatments can begin. Now, after the event, I spoke to some of the audience members to get their thoughts on the evening.
I thought it was very interesting, and I've always, like most people, believe sheep to be extremely stupid animals. So it was very interesting to have that confounded. Really.
I was very interested in it. It was very nicely introduced and gave me a real insight into what the researcher was doing and what it might lead to in future.
And what made you actually come along to find out more?
This is the first time I've come to one of these events. It's a subject area which is related to what I work on, which is why I was interested in it. But it's sort of certainly opened my eyes to. I'll look at what's on in future now. So I selected it based on an area of interest for me. But now that I've seen it, I think it'd be interesting coming again.
Well, this is the first time I'd been, and I was impressed at the level of the talk. I was slightly worried it was going to be too technical, but I thought it was really engaging for an audience who didn't know a lot about it, and it was very interesting.
And was there anything particularly interesting you found about the content today, so either to do with sheep or to do with Huntington's?
Well, I am actually a researcher. I work with mice and behavioral studies in mice, so it was really interesting for me to learn about how sheep are being used, the possibility of using sheep.
I like the topic because as a special needs teacher, I think it's the disease I've heard, but I've never actually known about it. So because I was invited, so I get the chance to Google it and been here to listen to a researcher sharing her experiments. So I find this really interesting.
And what about what she discussed did you find interesting? Was there anything in particular you found surprising or interesting?
I think the sheep experiment is interesting to know that actually could do some difficult executive tasks. Also changed my mind of sheep.
So a well-explained event, with many leaving with a newfound respect for the dozy, herd-following sheep. Now that's it for this month's podcast, but do join us if you can for the next Café Scientifique, which will be taking place on Tuesday the 12th of July at B Bar in Cambridge on Market Passage, where Dr. Linda Sharples will be discussing NHS rationing and the value of statistics when deciding this rationing, so a very topical event. You can find out more online at cambridgecafescientifique.com. Cambridge Café Scientifique is sponsored by the Medical Research Council, and this podcast was produced by me, Meera Senthilingam, from thenakedscientists.com.